So in today's episode, we will see the Numpy Universal functions. Hi, Pushparaj here. These universal functions allow you to create various functions and use various universal functions that are present in Numpy library, and also these can be used to define your own using a keyword that we will see in a short bit. So what are Numpy universal functions? These are used to vectorize the Numpy arrays or ND arrays as we call them. So vectorization is basically iteration based statements that will be converted into a vector based statements. So let's get into the first example. So here you can see I have a script which declares two arrays or two lists x5, where I have a iteration based operation and a vector based operation or a numpy based operation. So the advantage of numpy based operations is it is faster than the traditional iteration based operations, and you don't have to worry about any loop issues like the loop got terminated or anything like that. In vectorization, you just simply pass both the list or both the arrays into the function that has been implemented in NumPy, or you can also implement your own functions using from ufunc. This function makes you create your own function and add it to the NumPy library that we will see in a bit. So let's run the first script. So here you can see the vectorized version has a difference than the traditional version. So in the iteration based version, you can see the list has been converted into a list, but in vectorization or in NumPy, you can see the list has been converted into array, or we also call it as NumPy array. So let's move to the next script. As I was talking about from ufunc function, this allows you to create your own NumPy function and add it to the library. So here I am creating a myAdd function that will add two arrays and one output. Here you can see the definition or the declaration type of that function. So function name will be myAdd. Then the input will be the number of arguments, that is number of arrays, and the output will be number of output arrays that we will be getting. So as I am adding two arrays, it will give us one output array. We will pass two arrays to that function and it will give us one output array. So let's run this. The declaration for the function is same as the normal function that we defined, but using this function of NumPy, we can add this function into the NumPy library. So you can see here the output of the given two arrays. So you can use type function to check if your given function name, that is myAdd, is already present in NumPy library or not. So here, after declaring that function, or before declaring any function that you want to declare into NumPy library, so you can use this same this type function to check if your given function name is already present in the NumPy library. So we will just run this. So in the start only, it says that there is no attribute myAdd in NumPy. So we can say that myAdd can be a function that you can use or create using this function in NumPy. So when I comment this, so here I am checking for add function in NumPy, and yes, there is an add function in NumPy that will return you the type of that or the class of that function, that is universal function of NumPy. As you can see next in the list, you have arithmetic operations like add, which I have just checked here, then subtract, multiply, divide, power, mod, div, mod, absolute. We will check those in the next script. So let's go to the next script. So few of these functions are simple, like add, subtract, multiply, divide. So I will simply perform few of these operations like power, mod, and div mod. Here the power function in NumPy library gives you power of each element to the other element in the other array. For example, 10 to the power of 3, 20 to the power of 5, 30 to the power of 6, and so on. Mod function is simple as it will give you the remainder of the two arrays element wise. And in div mod, we will get both the quotient and the remainder. This is an interesting function, like you don't have to perform two different functions like divide and mod separately. You can simply call this function and have quotient and a remainder in a list format or in an array format, and use that array further. So let's run this. So you can see here, this is the div mod type. You have an array of quotients, you have an array of remainders. Here also you have an array of remainders, and this is the power function. Here it is 0 because it is going exponential. So let's move to the next universal function types. We have rounding decimal functions, which give you few functions that allow you to round up the value like closest to the decimal point they are. For example, I have taken all the rounding functions that are present in Numpy Universal library. So I will be demonstrating all of these, and we will check the difference between them. So let's run the script. You can see each of these functions have a kind of different impact on the number they are using. So start with truncate. So truncate will give you the smallest decimal value that it is closest to. So here you can see the smallest decimal value for minus 3.1666 is minus 3, and the smallest decimal value for 3.6667 is 3. Let's go to the fix function. So fix has a kind of similar operation as truncate. Then rounding. Rounding uses two arguments. One is the actual value that needs to be rounded up, and another is a number of decimal points it needs to be rounded up. Like for example, here 3.1666 has been rounded into 3.17, that is 2 decimals from the decimal point. So in floor, there is a certain change, as the minus 3.1666 moves to minus 4, whereas 3.6667 moves to 3, whereas in seal the reverse is happening. The minus 3.1666 moves to minus 3, whereas 3.6667 moves to 4.0. So these functions come in handy when you have to round up any decimal values or get the exact integer value for each of the decimal values that you have, or the floating points that you have. So next are log-based operations or log-based functions. So here you can also create a new log function using the from func operation or function that I discussed earlier. So here we have log to the base 2, log to the base 10, log natural log, that is log e, and any log that you want to perform using the from func. So we have a certain range of log operations that we are performing here. So let's check the values of each of these log functions. So you can see I have defined a range like 1 to 10, that will be 9 values. 1, 2, 3, 4, 5, 6, 7, 8, 9. These 9 values will be passed as an array into the log to the base 2 of Numpy, and the results will be printed. Then the log to the base 10 have a similar range 1 to 10, that is 9 values, will be passed to log to the base 10, and natural log same again, log to the base e or natural log. And next we have our own log function that is declared as nplog using the from func in np, where we are taking a log of 100 at the base 15 as two arguments, and we will get a return argument or return output of 1, and the function used is log from the math library, and it will be used under nplog this name. So you can see the output of it here. So that's it in the part 1 of Numpy Universal Functions. In the part 2, we will discuss more of Numpy Universal Functions that relate with distributions and other complex operations.